Hey everyone! Today we're diving deep into one of the most fascinating planets in our solar system, Jupiter. This giant planet isn't just stunning to look at, it plays a huge role in protecting us here on Earth. Let's explore everything you need to know about Jupiter. Alright, let's start with the basics. Jupiter is the largest planet in our solar system. It's so massive that you could fit over 1,300 Earths inside it. To put that in perspective, imagine stacking up 1,300 globes, one on top of the other. That's how big Jupiter is. Its diameter is about 142,984 kilometers, 88,846 miles, which is 11 times wider than Earth. Because of its immense size, Jupiter's gravity is incredibly strong. It's this powerful gravity that helps Jupiter protect the inner planets, including Earth, from potential cosmic threats. Jupiter is a gas giant, which means it doesn't have a solid surface like Earth does. Instead, it's composed mostly of hydrogen and helium, the same elements that make up the Sun. Scientists believe that beneath Jupiter's thick atmosphere lies a dense core of rock and metal, but it's surrounded by layers of metallic hydrogen, which is hydrogen that's been compressed to the point where it behaves like a metal. The pressure inside Jupiter is so intense that hydrogen atoms are squeezed together, creating this unique state of matter. It's a giant ball of gas with a tiny solid core hidden deep within. One of the most remarkable features of Jupiter is its atmosphere. Those colorful bands and swirling clouds you see in pictures are made up of ammonia crystals and other compounds that create beautiful patterns. Jupiter's atmosphere is divided into several bands that run parallel to its equator. These bands are known as zones and belts. Zones are lighter and are areas of high pressure where gas is rising, while belts are darker and are areas of low pressure where gas is sinking. This constant motion creates the stunning visuals we see and is driven by Jupiter's rapid rotation. Jupiter spins faster than any other planet in our solar system, completing a full rotation in just under 10 hours. A day on Jupiter is incredibly short. And then there's the Great Red Spot. This gigantic storm has been raging for at least 400 years, and it's so big you could fit 2 or 3 Earths inside it. Imagine a storm that huge. The Great Red Spot is a high-pressure region with winds swirling at hundreds of miles per hour. Despite its size and power, the storm is actually shrinking over time, but it's still a defining feature of Jupiter's atmosphere. Now, let's talk about Jupiter's role in our solar system. This planet isn't just big and beautiful. It's also like our solar system's cosmic bodyguard. Jupiter's strong gravity acts like a shield, protecting Earth and the other inner planets from comets, asteroids, and other space debris that might otherwise head our way. It's like having a massive bouncer at the door, keeping out the troublemakers. Over its history, Jupiter has pulled in or deflected countless objects that could have collided with Earth. Without Jupiter's protection, our planet would have been hit by many more comets and asteroids, potentially making it a much more dangerous place for life to develop. It's pretty amazing to think that this distant giant has such a crucial role in keeping us safe. Jupiter's magnetic field is another mind-blowing feature. It's the strongest of any planet in our solar system, about 20,000 times stronger than Earth's. This powerful magnetic field creates intense radiation belts around Jupiter, known as the Van Allen belts. These belts are filled with high-energy particles that can be extremely hazardous. Any spacecraft visiting Jupiter has to have special shielding to protect against this intense radiation. Jupiter's magnetic field also causes stunning auroras near its poles, similar to the northern and southern lights on Earth, but much more powerful and extensive. And let's not forget about Jupiter's moons. This planet has at least 79 moons, and some of them are absolutely fascinating. The 4 largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610, and each one is a world in its own right. Io is the most volcanically active body in the solar system, with hundreds of volcanoes on its surface. Some of these volcanoes are so powerful that they can spew material hundreds of kilometers into space. This constant volcanic activity is caused by the intense gravitational pull from Jupiter, which creates tidal forces that flex and heat Io's interior. It's It's like having a moon-sized lava lamp orbiting the planet. Europa, another Galilean moon, is particularly intriguing because it has a smooth, icy surface with a subsurface ocean beneath its ice crust. This makes it one of the prime candidates in the search for extraterrestrial life. Scientists are particularly excited about the possibility of finding microbial life in Europa's ocean, which could be similar to life forms found in extreme environments on Earth, like hydrothermal vents. If we ever discover life beyond Earth, Europa might be the place we find it. Ganymede, the largest moon in the solar system, is even bigger than the planet Mercury and has its own magnetic field. This magnetic field creates auroras near Ganymede's poles, much like the northern and southern lights on Earth. Ganymede's surface is a mix of two types of terrain: bright regions with ridges and grooves, and darker, older areas covered with impact craters. This suggests a history of geological activity, which could have included tectonic processes. Scientists think that Ganymede might also have a subsurface ocean, adding another potential location in our solar system where life could exist. Callisto, the outermost of the Galilean moons, is heavily cratered and ancient, giving scientists clues about the early solar system. Its surface is one of the oldest and most heavily cratered in the solar system, suggesting that it has been geologically inactive for billions of years. Despite its old age, Callisto is also thought to have a subsurface ocean, making it another intriguing target in the search for life. Each of these moons is a unique world with its own mysteries, and studying them helps scientists understand more about the formation and evolution of our solar system. Jupiter also has a faint ring system. While not as spectacular as Saturn's rings, Jupiter's rings are still pretty interesting. They're made mostly of dust particles ejected from its moons, particularly from impacts on tiny moons that orbit close to the planet. These rings are very thin and hard to see from Earth, but spacecraft like Voyager and Galileo have given us a closer look. The rings are divided into three main components: the halo ring, the main ring, and the gossamer rings. The halo ring is a thick torus of particles that extends inward toward Jupiter. The main ring is relatively thin and bright, while the gossamer rings are broad and faint, composed of microscopic debris from moons like Amalthea and Thebe. Exploring Jupiter has been a significant part of space exploration history. The Pioneer missions in the 1970s were the first spacecraft to fly past Jupiter and take close-up images of the planet and its moons. The Pioneer missions paved the way for the Voyager missions, which provided detailed images and data revealing Jupiter's complex atmosphere, its rings, and the volcanic activity on Io. The Galileo spacecraft, which orbited Jupiter for nearly 8 years, provided a wealth of data and incredible close-up images. Galileo was the first spacecraft to fly past an asteroid and to discover an asteroid's moon. It also deployed a probe into Jupiter's atmosphere, giving us direct measurements of its composition and conditions. More recently, we have the Juno mission, which is currently studying Jupiter's atmosphere, magnetic field, and gravity in detail. Juno has given us some of the most stunning images of Jupiter we've ever seen, revealing the planet's atmosphere in unprecedented detail. Juno's main goal is to understand the origin and evolution of Jupiter. By studying Jupiter, scientists hope to learn more about the processes that govern the formation of giant planets and the role they play in the development of planetary systems. Juno's findings could also help us understand the conditions that led to the formation of our own solar system. Jupiter's influence on our solar system is profound. Its gravity has helped shape the orbits of other planets and even influenced the formation of the solar system itself. Some scientists believe that Jupiter's movement in the early solar system might have played a role in the positioning of the other planets, possibly even affecting Earth's habitability. Without Jupiter, the layout of our solar system could be completely different. For example, Jupiter's migration could have helped clear out debris from the inner solar system, reducing the number of objects that could have impacted Earth. This could have been crucial for the development of life, as frequent impacts from comets and asteroids could have made the early Earth a much harsher place. Jupiter is also a source of endless scientific curiosity and wonder. From its powerful magnetic field to its diverse collection of moons, Jupiter continues to captivate scientists and space enthusiasts alike. The more we learn about Jupiter, the more we realize just how much it impacts our solar system and our own planet. It's like having a cosmic bodyguard and a scientific playground all rolled into one. Jupiter's vast and varied system provides a natural laboratory for studying the conditions and processes that have shaped our solar system and potentially others as well. Its sheer size and complexity offer countless opportunities for discovery and exploration. The exploration of Jupiter's moons, in particular, has the potential to revolutionize our understanding of where life might exist beyond Earth. Each of the Galilean moons presents unique environments that challenge our understanding of the conditions necessary for life. By studying these moons, scientists can test theories about the potential for life in extreme environments and develop new strategies for searching for signs of life on other planets and moons in our solar system and beyond. In addition to its scientific importance, Jupiter also has a significant cultural and historical impact. Throughout history, Jupiter has been observed and revered by many different cultures. It has been a symbol of power, authority, and protection in various mythologies, and has inspired countless stories, artworks, and scientific discoveries. The planet's prominence in the night sky and its majestic appearance have made it a source of inspiration and wonder for people throughout the ages. Jupiter's ability to protect Earth and the other inner planets is a reminder of the interconnectedness of our solar system. The gravitational interactions and dynamic processes that take place within our solar system have profound implications for the development and sustainability of life. By studying Jupiter and its many facets, we gain a deeper understanding of the forces that shape our universe and our place within it. Let's take a closer look at some more fascinating aspects of Jupiter. For instance, its rapid rotation rate not only contributes to its atmospheric dynamics, but also has a significant impact on its shape. Jupiter is not a perfect sphere, it's an oblate spheroid, meaning it's slightly flattened at the poles and bulging at the equator. This is due to its fast rotation speed, which causes the equatorial region to spin outward. Another interesting fact about Jupiter is its intense radiation environment. The planet's magnetic field traps high-energy particles, creating radiation belts that are among the harshest in the solar system. This radiation poses significant challenges for spacecraft and any potential human missions to Jupiter. The high radiation levels would require advanced shielding technologies to protect both instruments and astronauts. Jupiter's magnetosphere, the region of space influenced by its magnetic field, is enormous. It extends millions of kilometers into space, far beyond the orbit of its moons. The interaction between Jupiter's magnetosphere and the solar wind, a stream of charged particles emitted by the sun, creates spectacular auroras around Jupiter's poles. These auroras are similar to the northern and southern lights on Earth, but are much larger and more energetic. The study of Jupiter's auroras has provided valuable insights into the planet's magnetic field and the processes that generate these stunning displays. Observations from spacecraft like Juno have shown that the auroras are powered by particles that are accelerated along magnetic field lines into the planet's atmosphere. These particles collide with atmospheric gases, causing them to glow. By studying these auroras, scientists can learn more about the dynamics of Jupiter's magnetosphere and its interaction with the solar wind. Speaking of spacecraft, the Galileo mission was particularly groundbreaking. Launched in 1989, Galileo provided a wealth of information about Jupiter and its moons. One of its most significant discoveries was the detection of subsurface oceans on Europa and Ganymede. These findings have profound implications for the search for extraterrestrial life. The presence of liquid water beneath the icy surfaces of these moons suggests that they could harbor environments where life might exist. Europa, in particular, has garnered a lot of attention. Its icy crust is believed to be several kilometers thick, with a vast ocean of liquid water beneath. This ocean is kept warm by tidal heating, a result of gravitational interactions with Jupiter and its other moons. The heat generated by these interactions prevents the ocean from freezing solid. Scientists speculate that this ocean could contain the chemical ingredients necessary for life, making Europa one of the most promising places to search for extraterrestrial organisms. Ganymede, the largest moon in the solar system, also has an intriguing subsurface ocean. Its magnetic field, discovered by the Galileo spacecraft, is unique among moons and suggests the presence of a conducting layer, likely a salty ocean beneath its ice shell. The study of Ganymede's magnetic field and its interaction with Jupiter's magnetosphere provides valuable information about the moon's interior structure and the dynamics of its ocean. Callisto, although less geologically active than its siblings, presents its own set of mysteries. Its heavily cratered surface is one of the oldest in the solar system, offering a window into the history of the outer solar system. The possibility of a subsurface ocean on Callisto, combined with its relatively stable environment, makes it an interesting target for future exploration. Understanding Callisto's geological history and its potential for habitability could provide insights into the evolution of icy moons around gas giants. Beyond the Galilean moons, Jupiter's other moons also hold interest. For example, Amalthea, one of Jupiter's smaller moons, has an irregular shape and is thought to be composed of porous material. Studying these smaller moons helps scientists understand the diversity of objects that orbit Jupiter and the processes that shape their formation and evolution. Jupiter's role in the solar system extends beyond its protective influence and its moons. The planet's gravity has a profound impact on the orbits of asteroids and comets. The region of space between Jupiter and Mars is populated by the asteroid belt, a vast collection of rocky bodies. Jupiter's gravity helps to stabilize the orbits of these asteroids, preventing them from colliding with the inner planets. However, its gravitational influence can also send asteroids and comets on new trajectories, sometimes directing them towards the inner solar system. This dual role of protection and potential threat highlights the complex gravitational dynamics at play. Comets, in particular, are significantly influenced by Jupiter's gravity. Some comets are captured by Jupiter, becoming temporary or permanent satellites of the planet. Others are deflected into new orbits, either towards the outer solar system or into the inner solar system. These interactions with comets have important implications for understanding the history of our solar system. Comets are thought to be remnants from the early solar system, and studying their interactions with Jupiter provides clues about the conditions and processes that were present during the solar system's formation. Jupiter's gravitational influence extends even to the Kuiper Belt, a region of the solar system beyond Neptune populated by icy bodies and dwarf planets. Objects in the Kuiper Belt are thought to be remnants from the solar system's formation, and their orbits can be affected by the gravitational pull of Jupiter. By studying these distant objects and their interactions with Jupiter, scientists can gain insights into the outer reaches of our solar system and the processes that govern its evolution. The study of Jupiter is not just about understanding a single planet, it's about understanding the entire solar system. Jupiter's massive size and powerful gravity make it a key player in the dynamics of our planetary system. Its influence extends far and wide, shaping the orbits of other planets, asteroids, and comets. By studying Jupiter, scientists can learn more about the formation and evolution of our solar system and the processes that govern planetary systems in general. Looking to the future, missions like the Europa Clipper and JUICE, Jupiter Icy Moons Explorer, are set to further our understanding of Jupiter and its moons. The Europa Clipper, scheduled for launch in the 2020s, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. Its instruments will analyze the composition of Europa's surface, measure the thickness of its ice crust, and search for signs of recent or ongoing geological activity. By studying Europa up close, the Europa Clipper aims to determine whether the moon has the conditions necessary to support life. JUICE, a mission by the European Space Agency, will focus on studying 3 of Jupiter's largest moons, Ganymede, Callisto, and Europa. Scheduled for launch in 2022, JUICE will conduct detailed observations of these moons' surfaces, measure their magnetic fields, and analyze their atmospheres and subsurface oceans. By comparing these moons, JUICE aims to understand their potential habitability and the processes that have shaped their evolution. These missions represent the next step in our exploration of Jupiter and its moons. They build on the legacy of previous missions like Galileo and Juno, using advanced technology to answer new questions and uncover new mysteries. The data collected by these missions will provide valuable insights into the conditions necessary for life and the processes that govern the evolution of icy moons. Jupiter's exploration is a testament to human curiosity and our desire to understand the universe. From the early observations by Galileo to the advanced missions of today, each step forward brings us closer to understanding the complex dynamics of our solar system. Jupiter's immense size, powerful gravity, and diverse system of moons offer a natural laboratory for studying the conditions that lead to the formation of planets and the potential for life beyond Earth. As we continue to explore Jupiter, we not only learn about the planet itself, but also gain insights into the broader processes that shape our solar system and the universe. Jupiter's role as a protector, its diverse moons, and its powerful magnetic field make it a unique and fascinating subject of study. Each new discovery adds to our understanding of the cosmos and our place within it. So, next time you look up at the night sky and see that bright dot, remember that Jupiter is out there, not just being a giant gas ball, but playing a crucial role in protecting us, inspiring us, and teaching us about the universe. Thanks for tuning in, and until next time, stay curious and keep questioning.